Okay, this is going to be Math 2, Chapter 11, 34 to 37. On the first one it says, consider the circle that is centered at the origin and contains the point 0 and 3. Use geometry and the definition of a circle to prove or disprove that the point 1 comma square root of 5 lies on the circle. So I'm gonna actually draw this out really quickly because it makes more sense when you're actually looking at this. So let's tear this up and then calculate at least one value of x is at the point x squared of 5 lies on the circle. Well, it contains the point 0 and 3, so at least I know that the radius is 0. I mean, the radius is 3, so we'll see how this is going to look like. Okay, you're going to need a little bit of graph paper for this. So, there's my y, there's the x, it's centered at... centered at 0, 0. Okay, so there's a center, and the point 0, 3, so 0, 3 is up here, actually is on this circle. So if you think about it, if it's true that this point is on the circle, that means the circle is going to have a radius of 3 with the center at 0, 0. So it will look something like it's going to hit it here, it's going to hit it here, it's going to hit it here, it's going to hit it. The only way that a point is on the circle is if it actually belongs to the distance of the radius. So can I actually hit this spot? Yes, I can. Sweet. Whoa, that was pretty good. I'm not gonna lie. Oh, I'm off a little. Man. Alright, well, hopefully it doesn't mess up too much. So, this circle has a, what's the equation? So it's gonna be, x minus 0 squared plus y minus 0 squared equals 3. No, equals 9, sorry. Your radius is 3, but in the equation it's actually equal to 9. Alright, so we've got x squared plus y squared. Let's clean this up. So x squared plus y squared equals 9. Okay. That's a good one. Okay, use geometry and the definition of the circle to prove or disprove that the point 1 comma square root of 5 lies on this circle. Where's 1? 1 comma square root of 5. Isn't the square root of 5 like, what is the square root of 5? 3 point something something? I don't know what the square root of 5 is. Less than 3. Oh, well, that's not helpful. Go to classic mode. (2.2). Yeah, I don't think that's happening, but I guess we can check. Alright, 1 and somewhere around 2.2. So that's 1, that's 2. Yeah, I don't think so. It's not happening. And we can actually check. I don't know about using I would just plug it in. I don't know about you guys, but if that's 1 and comma square root of 5, I would actually just say, okay, well, this is x and this is y, and I would plug it in and check to see if it works out. So we have x squared plus y squared equals 9. Well, if x is 1, that'd be like 1 squared. If y is square root of 5, that'd be like square root of 5 squared. Is that going to equal 9? Okay, so let's see. 1 squared is just 1 plus square root of 5 squared is just 5. That 6 is not equal to 9, so the answer would be no. It does not. So we basically just disproved that 1 square root of 5 lies on the circle. So if it works, we should be able to plug it in and actually calculate it out. Okay. Calculate at least one value of x such that the point x comma square root of 5 lies on the circle. Okay, so we're just going to do the same thing again. So x squared plus y squared is going to equal 9. X is going to stay x. Square root of 5 actually changes here. So we have x squared plus square root of 5 squared equals 9. So I guess they want to know, well, we want to keep square root of 5, but what value of x do we need to actually have here? Because 1 didn't work out. So we have x squared plus square root of 5. Square root of 5 squared is just 5. If you don't believe me, I will do it on the calculator for you, because sometimes you guys just need convincing. Parentheses, second square root of 5, close parentheses again, and then square this thing. It is 5. Okay, you're basically just undoing the radical with the square. Is equal to 9. So x squared minus 5 on both sides is equal to 4. Square root both sides, so x is equal to plus or minus 2. Now, in this case, we're going to take both of those values because it is a circle. So that means when x is equal to plus or minus 2, so when x is minus 2 and when x is plus 2, the value of y is going to be right over here as, it's a little off over there, but I think this one's a little bit better. The value of y is actually going to be at root 5 right over here. Okay, so that's root 5 right there. This is squared. This is 2 and 2. So up here at these 2 points, because the circle is symmetric on both sides, you're going to have the value, so 2 square root of 5 is going to be one of the answers, and negative 2 square root of 5 is going to be the other answer. Okay. And then, what's the next one? Name 3 other points on the same circle. Okay, well, just look at it. You've got a point over here, you've got this point, you've got this point. I don't know, I guess you can use the top one too if you really want to. So you can actually go down too, because this is going to be the opposite of this one. So if it's at 2 and negative 2 here, it's going to be at negative square root of 5 down here. Negative square root of 5. The negative is not inside the radical sign, it's the outside of it. So it's just basically the opposite point of that one. So those 2 are also going to be your points you can use. Okay, 34 is done. 35. If the larger cube can hold 27 cubes of edge length 1 unit, then what is the edge length of the larger cube? Wait, what? Oh, it's 3, isn't it? Oh, yeah. So if there's 27 in here, then it would have had to be, okay, so let's say this is 1 by 1 by 1, right? This is 1 cube. In order to fit 27 of these guys in here, we should have a 3 by 3 by 3, I think. Yeah, 3 by 3 by 3. 3 times 3 times 3 is 27. 27 cubes of each of edge length 1. And you can actually, you can sort of... I'm just kind of like going, wait a minute. There you go. So this is 3, 3, 3, and it's going to be 3, 3, 3 this way. So when you're done with this whole piece, you actually have a, isn't this a Rubik? No, Rubik's Cube is a, oh, it is a Rubik's Cube. This is totally a Rubik's Cube. 3, 3, 3, 3, 3, 3. 3, 3, 3 all the way around. There's 27 of these guys in here. Okay. Then what is the edge length of the larger cube? It's got to be 3. Okay. All right. 37. Annie remembers the water balloon contest and wants you to try her skill at launching a balloon. So her balloon's flight can be modeled by the function y equals negative 1/2 x minus 1 squared plus 2, where x is the horizontal distance. The balloon traveling from the goal line. Y is the height of the balloon above the ground. Sketch a graph. Label the x and y intercepts. What do the intercepts tell you about the flight of the balloon? What's the maximum height? Okay, so I basically just sketched this out on Desmos, because, or not Desmos, it just kind of had it online, so I just took it down because there's no point. So here's the flight. Here's Annie, and then she's throwing a balloon. Here's the flight path, right? Can't be negative because it's not going to go behind her. So it starts, it's going to have to start at 1.5. So this is your y-intercept, right? Your vertex is going to be at 1, 2 because, and you can actually check that from the original graph because it's at -1 in the parentheses plus 2 over here. And then it lands 3 feet from where the goal launch was. So this is your x-intercept, and it really wasn't, she wasn't behind, but I mean, if you want to say something about the trajectory of the actual parabola, you can say that maybe this is your other x-intercept down over here, And what's the maximum height the balloon reaches is pretty much your vertex, because anytime you have a downward opening parabola, the maximum is your vertex. Okay, that was 36. 37, Jamie reaches the balloon dance. What? The balloon dance. Oh, wow. That sounds pretty interesting. The ballroom dance at a dance studio teaches. Okay. She teaches in a ballroom dance. She teaches ballroom dance at a dance studio. Each month she offers a series of group classes for a charge of $45 a person. Okay. Write a function f to represent Jamie's monthly earnings based on the number of participants. Well, let's just f of n, or the function. Jamie makes n number of 45 times the number of participants. An appropriate domain is a set of all whole numbers, because you can't you can't have like half a person show up. So you only have one person, two people, three. So whole numbers are 1, 2, 3, 4, 5, dot, 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 right? And we can't have negative people show up, because that would mean they were ghosts, and that would be weird if you were in a ballroom when there were a bunch of ghosts dancing around. So, Jamie rents a large room at the dance studio for $1,200 a month. Write a function p to represent Jamie's profits based on the number of participants. How many participants does Jamie need to make a profit each month? So, she must be greater than 12. Oh, this is a guy? I thought this was a girl. Because it says she. Oh, seriously, look, it says she. She offers a service of something, something, and then they say something about Jamie, and they say him. What? Okay. Never mind. So her earnings must be more than $1,200 to make a profit. So if the function is y equals 45n, then y, being the money that you make, has to be this, the number of people that show up have to be, I don't know, I guess you can say. So let's see. This is how we typically do it in Math 1 when we are not sure. Let's say 10 people show up. Well, 10 people times $45 a person is just 450 people. Okay, well, that's not enough to cover your rent, and you're definitely not making a profit. Well, what about 100 people, right? Well, that's a little bit better. So 4500. Oh, okay, well, now we are getting somewhere. So we are going to make a profit if 100 people show up. But between 10 and 100 is a lot of people. So you got to sort of narrow it down. So you're actually finding the boundary point. When is 1200 going to equal 45n, because that'll give you your boundary point. So let's see, 1200 divided by 45. 1200 divided by 45 is n equals 26.6. Okay, well, you can't really have 26.6 number of people. A six-tenths of a person doesn't make any sense. So realistically, it's got to be around n equals 27, because if you go to 26 people, so 45 times 26 people, 45 times 26 is just 1170. You haven't made enough to cover your rent, and you're still not making a profit. But 45 times 27 people is going to give you 1215. Well, that's not much of a profit, but at least you covered your rent, right? So over 27 number of people is really what you're looking for. And your answer should be n. The number of people who show up to this ballroom has to be greater than or equal to 27. Okay? Has to be greater than or equal to 27. We can't have it less than that, because if we do anything less than 27, we're in the red. Okay? All right, so that's 100. That was 37. Okay? See you guys tomorrow.